Welcome students to another video lecture with Mr. Kinnett. I know it has been a while. So we're moving on to chapter 12 now that we've completed chapter 10, and what we're first focused on here are circles. So we're going to try and learn about the vocabulary for a circle and how to use circumference and area formulas of a circle to solve problems. Go ahead and pause here and copy down what you see. Okay, welcome back. Our essential question on our circle lesson today is, how do we find the area or circumference of a circle? And I think we've already seen this in our past, so we're going to go a little beyond that. We're going to find multiple areas of a circle and multiple circumferences and trying to compare and contrast different circles. So I'm going to go to the next two slides and have you copy down what you see. So go ahead and pause here and copy down what you see. Nice, welcome back. Okay, so the left slide here, what we need to talk about first is a couple vocabulary words, or refresh yourself on a couple of vocabulary words about a circle. So first off, this black dot in the dead center of our circle here is the center. It's important to realize that dot is the center. All of this is based off that being the center. Okay, so the blue word, the diameter, that is the distance across the circle going through its center. The R word, or the radius, is the distance from the center of the circle to its edge. And the radius is the same no matter where we make that measurement. We can rotate our circle around, but that radius won't be changing, nor the diameter will, because they're always going through the center of the circle. And then this green concept is our circumference, and that's the distance around the circle. And that's really synonymous with rectangular or square or triangles perimeter. So circumference is just the distance around a circle. And then the last thing that's not really on the picture is area. And area is the amount of space inside of the circle. So the area of a problem is going to be the amount of space inside of a circle. So this is a circumference of the circle. The area is the inside of our circle, all of this space in here. Okay. And then we have some formulas, our circle formulas. This first formula is diameter, d, equals 2 times the radius. So anytime you find a diameter, and check the picture, this should make sense, a diameter is just 2 radii. So the diameter formula equals 2 times the radius. Circumference is always equal to the diameter times pi. And that is the pi symbol. And we're going to have to remember that pi is an irrational number, which means it never terminates and it never repeats. So whenever we use pi in our formulas as a decimal, we're going to have to approximate it. And we're normally going to approximate it to its 100th place of 3.14. But please remember, it doesn't actually stop there. Pi goes on forever with never terminating or repeating. And we'll talk about finding pi in class next week. The last formula we want to know here is the area of a circle. So A with that little c is going to be the area of a circle. And we're going to want to use that subscript in this chapter because we're going to have a lot of area formulas for different shapes. So please make sure to be using that subscript. And subscript is that little letter I'm putting below the A. That's the area of a circle. And then I just listed what these things mean if you have forgotten on the right side there. Okay, so now we're going to learn how to use these in problems. So go ahead and copy down example 1 now. Okay, welcome back. I hope you paused. I forgot to mention that. This is going to be like our basic problem. Let's go ahead and circle what they give us, because the key to most of these problems is to realize they have to leave only one thing out. They have to give us enough of everything to solve the problem, but one variable is always going to get left out, and that's the thing we're finding. So they give us the circumference of the circular field is 241.78 yards. Our goal is to find the diameter, and they do remind us that the pi we're going to use is 3.14. Okay, so they have mentioned in this problem pi, diameter, and circumference, sorry. Which formula should we use? Yeah, you're right. So our first step here is going to be write the formula. So it's going to be really important. Anytime in this chapter we use a formula, just like other chapters, we write the formula down first. And the formula we're going to use is circumference equals diameter times pi. Second step in any formula problem is going to be to use that S skill we learned way back in chapter 1, and we have been recycling nonstop. What's that S skill from chapter 1 called? Really vital skill that we use a lot. If you still haven't got it, it's the name of the person who replaces me in class when I'm not here. Yeah, it's substitute. So we substitute what they gave us into our problem. So they gave us the circumference. So instead of C, right below C, we'll write 241.78 equals, we don't know what D is because that's the unknown in the problem. And they told us to use a pi of 3.14. Okay, so we substitute it. Now, how do we get the variable by itself? Well, the last step is going to come from chapter 8's vocabulary. So again, if you're confused at all on how to get D by itself, just looking at it right now, please go back to chapter 8 and start reviewing those Piom steps. Yeah, that's right. You're going to use Piom nonstop. You're right. What we're going to do here is just solve. And that's the direction. So for any of our problems we're going to do mostly in this chapter, it's going to be write the formula down. Second step is substitute. Third step is solve. So we're going to draw our line because I reviewed in chapter 8. I see that there's multiplication here in the problem, so I have to use the multiplicative inverse. And that would be 1 over 3.14, which is the same as dividing by 3.14. I like to use this if fractions show up. And it says do not round our answer, which should be a hint that we're going to get a diameter that's a whole number. And when you divide 241.78 by 3.14 in your calculator, go ahead and do that. Awesome job. You have just discovered the diameter is 6. Now we want to make sure we answer the question, preferably with some words just in case. The diameter of the circle is 6. 6 what? What unit were we supposed to use in here? Ah, yes, 6 yards. Yeah, awesome job. And that is really what we're going to do on most of our problems in this chapter. We're just going to have more steps or multiple circles to evaluate. So let's go on to example 2. Here we go, example 2. And I will give you the heads up. Example 2, I tried to select the hardest possible example of these problems. They won't all be this challenging, but for most of example 2 problems, what you're going to want to do is draw a picture to try and understand what they gave you. So go ahead and pause here and copy down what you see. Awesome, welcome back. Okay, so let's circle what they gave us. They told us there's a street that's 168 feet long. I don't care, it's covered in snow. Good enough. Okay. We're going to use a snowplow. And this tire, well, a tire is what shape? Yep, you're right. It's a circle. Has to turn 28 times to travel the whole length of the street. Okay, well, this was a little confusing for me, so I'm going to draw a picture. I'm going to say we have our street here. Yeah, that's me drawing snow right now. And we know that this whole thing is 168 feet long. And then we know that the tire of this snowplow, and I'm just going to simply draw a simple circle, has to go around itself 28 times. That means once it rolls once, and then again, and then again, and then again, and it does this segmenting of the tire 28 times. I wonder what operation we need to do with the 168 and the 28 in order to find the tire's circumference. Did you think of an operation yet? You're right. Anytime we take a larger piece of information and chunk it down into equal groups, that's not multiplication, that's division, equal groups being segmented. So to find the shape's circumference, or the tire circumference, we have to take the 168 and divide it by 28 first. And we can stick that in our calculator. And you should come up with something that I do similar to me, and you came up with the number 6. And what unit are we using? We're using feet. Good. Okay, 6 feet. But the question doesn't want the circumference. It wants the diameter of the tire. Well, we have to do another step. So we have a circumference. It wants to know the diameter. And look at that. It told us what to use for pi again. So when we go to our formula sheet, we're going to use the formula for the circumference, which is still C equals D times pi. And we're going to substitute into that formula. We know the circumference is 6. We do not know what the diameter is, and they told us to use 3.14 as pi. Now, how do we get the D by itself? Yeah, you're right. We're going to divide both sides by 3.14, which is the same as using its reciprocal or multiplicative inverse. And I just want to check my directions real fast to make sure. It does mention that we're going to probably round. Yep, it does want us to round to the nearest tenth. And this do not round in intermediary steps means don't round until the last step. It doesn't want you to round any other time but the final line. And the reason we do that is it can mess up our answer if we round in the middle, the intermediary. So let's go ahead and type in 6 divided by 3.14 into our calculator. And you should get something similar to me. I got 1.1, nope, not 1, 9108 keeps on going. Well, now we have to round that to the hundredths or tenths place according to the directions, which is 1.9. You're right, and our unit is still going to be feet. So, can't hurt, but let's write a little sentence here for our answer. The diameter of the snow plow tire is 1.9 feet. Well, we got one more example from 12.2. And I'm going to have you just copy down this picture. And then we can go over this one in class. I like to leave one. But go ahead and start to hypothesize, how do you think we're going to find the area of this shaded circle when they've given us the diameter of this inner circle and this little piece up here that's 2 more centimeters? I wonder. Well, go ahead and have this copy down for class, and we're going to continue this part inside of our class. If you have any questions, please write the questions or any extra notes in this column here, and go ahead and let us know what you did in class. Remember, it's okay to add to these notes. Hope this works out, and I'll see you really soon. Bye, y'all.